So dimensional analysis is the fancy phrase unit conversion. We are going to, later on this year, memorize a couple of shortcuts because we're going to be using them over and over, and that's the only time it is worth memorizing something, when we're lazy. But for now, starting out with the metric prefixes, I think of these as one-step conversions. And what I mean by that is we're either going from a metric prefix, mega, to no prefix, or we're going from no prefix to a prefix. Two-step questions are where you're going from one metric prefix to another metric prefix. I hate memorizing stuff. To me, memorizing stuff is useless unless you're lazy and you're using it all the time, then it's worth memorizing. So the method that I'm going to give you does not require memorizing any shortcuts or gimmicks or anything like that. And I always try and start out, you're going to find my method of teaching. One of the things I'm really big on, Danveer. Yes, I got it right the second time. Still, I got half of it right. One of the things you're going to find is I'm big on getting you to write something down almost mindlessly so that your question is no longer blank, because I think that gets the mental juices flowing and the dominoes start to fall into place, and often that'll get you going to the answer. So whenever I'm doing a unit conversion question, the first thing that I always do is I write down what they gave me. 12 megagrams. Deegan, have we written something down? Is the question blank, staring us in the face anymore? No. Am I more relaxed? Do I feel better? Done. Okay. Then I'm going to multiply by a fraction, a conversion factor. Now, you need to realize when I say multiply by a fraction, what I'm really saying is I'm going to go top times top, bottom times bottom, and I'm never going to write this again. Don't write this down, but please understand that that's technically anything is over 1. Every number is actually a fraction in disguise. Yes? You've learned that? Okay. What units do I want to get rid of? Megagrams. Where is megagrams in this first fraction? On the... It goes in the bottom in my next fraction. What units do I want to end up with? It goes in the top, except this is not a conversion factor because grams and megagrams are not the same. What is the power of 10 with mega? 10 to the what? 10 to the what? The question is then, where does that 10 to the 6th go? It always goes where the metric prefix isn't. So since the metric prefix is on the bottom, the 10 to the 6th will go on the top. Now, you might be saying, Mr. Duick, look, I know all I had to do was multiply by 10 to the 6th. And this is why I said, if you got a shortcut that works for you, great. But this is a one-size-fits-all method that will work for much more complicated ones, which we're going to get to. Now I pull out my trusty calculator. Now we all pull out our trusty calculator. It's going to be top times top and divide by anything on the bottom. Are there any numbers on the bottom? Just invisible ones. So it's just going to be 12 times 10. You need to know where your exponent button is. I think we pulled that out last class, to the 6th power. And I get how many zeros? A 12 with 6 zeros. You can write as your answer 12 with 6 zeros. Would it be less writing to write that in scientific notation or to write? So I'm going to choose to write my answer in scientific notation since the question didn't give me any specific instructions. Apparently it's allowing me to decide. So I'm going to write this as 1.2 times 10 to the 7th. Good. Units, I will take a half mark off if you forget the units. I played for you that Verizon phone call last class, which always just drives me crazy. Units matter. By the way, I will almost always do that so you can see it's a 7 from the back row and not a 1. And the other thing, that's a 2, that's a Z, if we're using Z as a variable or something like that. So I'll try and come up with a way so that in the back row, because my writing is atrocious and it's made even worse by writing on a slippery tablet like this. Number 2, Oh, and you know what I'm going to do first? Write down what they gave me. 13.6 amps times fraction. I guess this time I want to get rid of just plain old amps. Where is amps, Owen, in this first fraction? On the, it's going to go on the bottom. What units do I want to end with on the top? What's the lowercase m and abbrev for? Milliamps. I'm not done because I haven't yet replaced the power of 10. Owen, milli is 10 to the what? Where's it going to go? Where the metric letter isn't. Don't try and memorize top or bottom. You can memorize where the metric prefix isn't. That's where the number goes. 10 to the negative 3. Because it's on the bottom, will I multiply or will I divide by 10 to the negative 3, Owen? Oh, very good. I'm so proud of you. Well done. So it's going to be 13.6 divided by 10 exponent button negative 3. This is not scientific notation, even though it has powers of 10. So you'll notice I'm not, Nick, using my scientific notation button, that exp or that EE or that times 10 to the. You get 13,600? You know, I think I'll write it as is. I think writing it out in scientific notation is about the same length, but I'm then too lazy to even use my brain to do the conversion to scientific notation. So how about 13,600 units, Owen? Yeah, milliamps. By the way, you'll learn in Physics 12, milliamps is also nicknamed the death current. If you get shocked with milliamps, that's enough to kill you, so don't muck around with electricity. Two-step questions. I want to convert from kilograms to, what's that funky symbol? Annika, micrograms. How many steps? 2. You know what I'm going to do first, Annika? Write down what they gave me. So I'm going to write down, and I'm going to zoom in a little bit so you can see in the back. I'm seeing some of you squinting a bit. So I'm going to write down 13.6 kilograms. Here's the strategy. I'm going to get rid of the kilo. That's step 1. And I'm going to bring in the micro. That's step 2. I want to get rid of the kilo. I'm going to multiply by a conversion fraction. Peniel, where is the kilograms, on the top or on the bottom of my original fraction? It's like that, is it? Okay. So where am I going to put it in my conversion fraction to get it to cancel out? On the... What's going to go on the top? Just plain old grams, because my first step is to get rid of the kilo. Except I can't write that. I need the conversion number that goes there. Kilo on your green sheet is 10 to the... Good. Where's it going to go? Where the metric prefix isn't, which in this case is on the top. If I stopped here, the kilograms would cancel. This would be grams. But what do I want my final answer to be in? So, another conversion factor, fraction. I want to get rid of grams. Where is grams in this fraction? On the... Where's it going to go in my conversion fraction? On the... Grams goes there. I introduce micrograms. Micro, Peniel, is 10 to the... Where's it going to go? Don't memorize top or bottom. It's going to go where the metric symbol isn't, which in this case, that's where the gap is, 10 to the negative 6. So get your calculator out. It's going to be 13.6 times 10 to the 3 divided by 10 to the negative 6. Oh, by the way, also technically there's a 1 there and a 1 there. Does multiplying by 1 or dividing by 1 change our answer at all? We're going to skip the 1s then, okay? Did you all? Oh, mine gave me an answer in scientific notation because there was too many zeros to fit on my screen. Some of you might have a 10-digit calculator. I don't know, but mine gave me 1.36. And I know when is that right? Is it 1.36 times 10 to the 10th? And I know that on my calculator, Alessio, that E is times 10 to the 10th. Please don't do this. Those of you that have TIs, don't write this down. Please don't write your answer as 1.36 E 10. It's 1.36 times 10 to the power of 10 micrograms. You get that okay, Neil? Got that all right? Be honest. Okay, good. Let me pause. Now is the chance for you to figure out how your calculators work a little. 4. Also a two-step question. Looks like I'm going from, what's a lowercase n? What's an L? Yeah. And again, we're going to have to realize the second letter is the actual quantity, amps, liters, meters, seconds. The first letter is the metric prefix, right? And I want to end up in mega liters. Okay. George, what am I going to do first? Write down what they gave me. I feel so much better. 2,000 nanoliters. Oh, one more thing. I will always make my lowercase l's like that. Why wouldn't I draw my lowercase l like that?
Looks like an I.
Looks like a 1. Doesn't look like an I. There's no dot on it.
Yeah.
Okay? So you're going to notice I will always do a lowercase l in cursive, and that way I know it's an L. Alrighty. We're going to multiply, George. Are you ready? Big fraction bar. What's going to go in the bottom of this next fraction? Good. What's going to go on the top? Just plain old liters. Nano is 10 to the? Where's the 10 to the negative 9 going to go? Don't memorize top or bottom. It goes where the nano is not. So in this case, on the top. If I stopped here, that would be just liters. Oh, by the way, what if nanoliters had been on the bottom? Where would it go in my conversion factor to get it to cancel? On the? And now we'll have some like that coming up, but it's going to flow nicely. Okay. Times, now I want liters to cancel. I want megaliters left behind. Mega is 10 to the... If it's on the top, we multiply. If it's on the bottom, we divide. Those of you who I helped with your calculator, try this as well, because this is your chance to see if you figured out how to type this yourself. On your quest, which is probably going to be Wednesday during Y block, you'll probably have 8 or 10 little unit conversion questions, probably 1 or 2 one-step questions, 2 or 3 two-step questions, and we'll build from there. Then we'll go to multi-step. It's going to be 2,000 times 10 to the power of negative 9 divided by 10 to the power of 6. Do you get 2 times 10 to the negative 12? Yeah. 0.00, 11 zeros after the decimal point, and then a 2 if you want to write it out longhand. Who does? So 2 times 10 to the negative 12 megaliters. Number 5, 342.5 kilometers to millimeters. Okay. I don't know how to start this. Oh, yes I do. Okay. I'm going to pause and freeze my screen so you can't see what I'm doing. Try this one on your own. Let's see if we end up in the same place. Screen frozen? Yes, it is. I got that. I wrote it in scientific notation because it was less writing. How many zeros? I think 5? Yeah. 3, 4, 2, 5, and 5 zeros. How many of you got that okay? Most of you? Good. Good. The reason I'm so bullish on this method is you can continue to build a fraction unit conversion chain, and you can use knowledge that you've already memorized without having to memorize extra knowledge. This is how by the way, if you're wondering, on the calculus test, the question is what's called a mixture brine question. It went something like this. You have a 500-liter tank. The tank is draining 5 liters per minute. We are pouring in 4 liters of a 40% salt solution per minute. After 50 minutes, what percent of the tank will be salt? So you're draining at a different rate that you're pouring in. You're adding a percentage of salt. And there's a way to do it in a couple of lines in calculus, but I built, I think it was like a 9 or 10 term fraction chain. I got there. Worked. Just not the easiest way to get there. So units matter. Verizon can't count. Multi-step conversions using conversion factors. Example 6. How many seconds in 1 week? My first question is, does anybody know how many seconds are in 1 week? Because if you know this, you can just write down the answer. No? Okay. How am I going to start this? How did I start every other question that we've done so far? 1 week. I'll use W for week. What can I break weeks into? This is something you have memorized. Days. So it's going to look like this. Here's my conversion fraction. Annika, where is weeks in the first fraction? Top or bottom? So I want it to go in this conversion fraction on. And what did you say that you know? Days on the top. How many days is how many weeks? So you could either write 7 and 1. If you were silly, you could write 14 and 2 or 21 and 3, but I just used the simplest conversion factor. The nice thing is you've all memorized that because, you've grown up. If I stopped here, that would be days. Does anybody know how many seconds are in a day? No? Okay. What can I break days into? You've all memorized this because you've grown up. Where is the days going to go in my next conversion factor? Where am I going to put hours? How many hours is how many days? So you can write 24 and 1. If you were silly, you could write 48 and 2, but yeah, 24 and 1. If I stopped there, that would be how many hours are in a week. But I want to get to seconds. Does anybody know how many seconds are in an hour? Okay, what can I break hours into? Good enough. Hours on the bottom. For minutes, don't use a lowercase m because that's meters and you will get confused. So for minutes, I always go MIN. How many minutes are in an hour? So you could go 60 and 1. You could go 120 and 2. That would just be silly. But you could. Do I know how many seconds are in a minute? So where is minutes going to go in my last fraction? On the seconds on the top. Where is the 60 going to go? Here, here. Now, Mr. Duick, what if I could just figure this out on my... Again, I don't care if you... Fine. But the question kids always ask me is, Mr. Duick, do I divide the numbers or multiply the numbers? This answers that. If it's on the top, you're going to what? If it's on the bottom, you're going to... So now I know it's going to be 7 times 24 times 60 times 60, which is what? How many seconds in a week? 604,800? And the nice thing with that method is we were able to use conversion factors that we've just memorized already. What's your question? How many what are in a year? We're going to calculate that in number 8. Patience, grasshopper. How about, let's start with number 7, Alessio. How many hours in a year? Does anybody know? Because again, if you, no, great. No. So, how am I going to start? By the way, technically the correct abbreviation for year is a lowercase a for annually. The reason is a lowercase y is yards in the US system, but if you write y, I'll figure it out. The correct abbreviation for year is A annually. You can write 3 letters when you only need to write 1, but if you haven't figured out yet that I tend to abbreviate and that I'm lazy and organized, go ahead. I'm not going to write more information to be wrong. Please. Okay. What can I change years into? I think I'd go with days, because if I went to months, what would you do next? You'd be going days, but the days are inconsistent for months, right? Sometimes 31, sometimes 30, 28. Oh, every 4 years, 29. So I would go with days. Years on the bottom, days on the top. Hey, how many days are in a year? Can I go from days to hours? Oh, good. So days is going to cancel. Hours is going to go on the top. 24 hours is 1 day. And again, you might be saying, Duick, I know to go from years to hours, it's 365 times 24, and I'm fine if you just do it that way intuitively. We've kind of proved why that works, but this method will also work when you don't know how to get there. What is 365 times 24? 8,760? Is that right? No? Yes? Yep. Units? Let's now answer Alessio's question. How many seconds are in 1 year? Well, let's start out writing down what they gave me. 1 year. What can I change years into? If I'm clever, like Aiden, what can I change years into if I'm paying attention to that which I just finished calculating? Darn right, I can go straight to hours. So the message I also have for you is, in the homework, if you've originally figured something out and it'll get you there shorter, go ahead. That's probably why I stuck it in there earlier, to see if you're paying attention. So I'm going to go from years to hours, because apparently 8,760 hours is 1 year. If any of you have seen the musical Rent, you may have memorized a catchy song there which tells you how many minutes there are in a year, I think. And so I've had some kids that could go straight to minutes from years because they knew that song. You can Spotify it. Remind me later on during Y block and I'll find it for you, because it is a catchy tune. Okay? And I want to go seconds. How many seconds are in an hour?
360.
Okay. George has permission to go with a shortcut, because George has noticed that it's 60 minutes and 60 seconds, and he said, I'm pretty sure there's 3,600 seconds in an hour. And since you happen to have memorized that conversion factor, as far as I'm concerned, you could put H here, S here, and you're done. Since nobody else said that, the rest of us, we're going to have to go schlepping along and say hours, minutes, 60, minutes, seconds, 60. But now we can answer Alessio's question from earlier. How many seconds in a year? Do you get 3 1 5 3 6 and 3 zeros? You know what? It's going to be shorter to write it out longhand because I'd have to write out the 3, the 1, the 5, the 3, and the 6. And then the times 10 to the is about the same amount of work as writing those 3 zeros. So I'm going to write 31536 with 3 zeros. And that's seconds, and I'll go back and stick. Alessio, can you read that number out to me? 31 what? Basically 31.5 million, roughly, seconds per year. Do I need to memorize that? No, I can figure it out in 2 seconds. A little shorter if I have George's 3600 conversion factor. Next page. I can also, if you give me a chart of conversion factors, build a chain myself. This is the US system, the imperial system. It's stupid. The metric system, it's all powers of 10, so it's pretty easy to wrap your brain around. And the 10 times table is the third easiest times table after the ones and the zeros, right? The imperial system, dumb. Anyways, okay, how many centimeters in 1 mile? What am I going to do first? What did they give me? And the abbreviation for mile is MI. MIN is minutes, just M is meters. I know nothing about miles, so look in here. Is there anything that we can change miles into from here? Feet? So where is the miles going to go in my second fraction? Feet goes on the top, and apparently 5,280 feet, what a stupid conversion factor, is 1 mile. So if I stop there, I'd be feet. I want to get to centimeters. Is there anything here that helps me? Sadly, not really. By the way, what's the only centimeters here? Okay, somehow I need to get this into inches, and I'm gambling because you've grown up fairly close to the US and that because you watch mostly American television, that you probably have memorized how many inches are in a foot. If you know the 12, I can pull that out of my brain without needing a chart. So I'm going to then go, okay, feet, inches, 12 inches is 1 foot. And now, hey, I got inches and centimeters. I can make this work. I'm going to go inches right there, centimeters right there. And apparently, 1 inch is 2.54 centimeters. Mr. Dewick, we're multiplying all the time. The numbers have always been on the top. That's because I'm giving you fairly easy ones. That we'll get to some where we have stuff both on the top and on the bottom. So the rule is if it's on the top, multiply. If it's on the bottom, divide. Do you get 160934.4? You'll also notice I'm ignoring sig figs right now. Conversion factors are assumed to be an infinite number of sig figs, so we just kind of ignore it. In other words, for metric 10 to the 3, that 10 technically is 1 sig fig. No, it's actually 10.00000000000 because it's defined that way. 160934.4. 160934.4, and this would be centimeters. I like number 10. I like number 10. I like number 10. Number 10 is a nice question. Why would I say that? No. Yeah? No, not yet. I'll come back to that. Hold your question. I like number 10. I like number 10. I like number 10. Number 10 is a nice question. Why would I say that? Wow, this may be the first class that hasn't figured me out. This might be a nice question that you might see somewhere in the future. Why would a teacher say that they like a question or emphasize a question? Because it's going to be on the test. Did you hear me say that? No. If a good student, if you're paying attention, you might notice when your teacher emphasizes certain things. I like this question. I like this question. I like this question. Nick, you had a question and I cut you off because I was in the middle of my rant. Do you know how many centimeters are in a foot? Is it exactly 30? I don't know, so I skipped that. I know it's exactly 12 inches, and then I use their conversion factor. You could try it with the 30 and see if we get the same. I bet you'll be off on the last two sig figs, probably. So, number 10, convert 60 miles an hour to meters per second. In physics, we do all of our velocities in meters per second. In the US, they do feet per second or miles per hour. Now, I have a bit of a clever trick. I know that converting miles per hour to meters per second, it's always just a bit less than half. So 60 divided by 2 is 30. I'm going to tell you right now, the answer is going to be around 26 or 27. That's just a trick I've picked up over the years converting American units to physics units. But for now, how am I going to start? Write down what they, darn right. And I'm not going to write MPH because I want to keep the fraction. I'm going to write it like this, 60 mile per hour. Never write slanty fractions, always write a top and a bottom. That way you can clearly see what's on the top and what's on the bottom. This is going to be multi-step. This is going to be multi-step. Oh, and it seems to me that I'm going to have to convert miles into meters, and I'm going to have to convert hours into seconds. We'll do them one at a time. Oh, and what you want to do first? Miles to meters or hours to seconds? I don't care. Pick. Miles? Okay. Where's miles going to go in my next fraction? I think you said bottom, yes? What am I going to put on the top? What can I change miles into? Do I? Can I? Now, I could look at that chart that I gave you, and I could say 5,200 feet. But what did we just figure out in number 9? Why don't I go from miles to centimeters and then from centimeters to meters? Because I think I can do that in 2 steps without having to rebuild that chain. Is that okay, Owen? So I'm actually going to put centimeters on the top, and the conversion factor is 160,934.4 to 1. Is that all right? Yeah. So if I stopped here, this would be centimeters per hour. I need to get rid of centimeters. Oh, and where is it going to go in my next fraction? On the? Yes. What am I going to put on the top? Yep. What's the conversion factor between centi and meters? That's on your green sheet. 10 to the something. 10 to the negative 2? Where's the 10 to the negative 2 going to go? Where the metric prefix isn't, which in this case is on the top. Well done, Owen. You got us from miles to meters in about the shortest way possible using something we already calculated. That's good. I like that. Kiana, now I want to take care of hours and change it to seconds. Where is hours right now? On the? Kiana, where's hours right now? On the? Hours is on the top right now? Sesame Street is brought to you today by the word, right? It's on the bottom. Where is it going to go in my conversion factor? On the? One of those is correct. That's the good news. So since it's on the bottom here, it's going to be, okay, there we go. What do I want to change hours into? Do you remember George's shortcut for hours to seconds? I'd love to use it, but if you can't remember, the pressure's on, then we'll have to do it in 2 steps. Oh no. Do you remember how many seconds there were in an hour? Max is just bursting to save us some time. Max, go ahead. Now, otherwise, you would go hours on the bottom, minutes here, minutes on the bottom, seconds here. But I've been talking for a while, and I can see you're zoning out. So let's go seconds on the bottom, which, by the way, is where we want it in our final units. Because, look, it's on the right-hand side of the fraction. We do want it on the bottom. And it's going to be 1 hour is 3,600 seconds. So look up, everybody. I need to teach you all an important new button on your calculator. How many of you still have the 160934.4 sitting on your calculator screen? Yeah. Okay. Do all of you know where your answer button is? All of you have a previous answer button. It's usually either right next to your equals, or it's second function right next to your equals. Sometimes it's alpha equals, but I'm going to go like this: 60 times answer button. Why would I retype that if I don't have to? It's more accurate, it's less error, and it's less work. It's a triple win. Times 10 to the negative 2 divided by 3,600. If you don't know where your answer button is, now is the time to raise your hand, and I will show you where this most useful of buttons is. Who doesn't know where their answer Yep. Trust me, I'm doing you a huge favor. We're always going to be using our answer. Yours is going to be second function.
This 25. I do.
Anybody else get their answer? Want to find it? Like the Casios, I think they have an A and S and amp button. Yeah. And you'll notice also I deliberately haven't hit equals, so you don't know if you got it right yet. Oh, you sort of do, because I told you it's going to be like 26, 27-ish. It's a little less than half is the little trick I do all the time. Oh, I forgot to pause the video there. Okay. 26.8 meters per second. I went to 3 sig figs because after the 8 was a 2, it looked like that was a pretty good place to round up. Couple more and we're done. Number 11. Yeah, there's another page, but back to here. It's called detention span. Convert 4,356 terameters per year to kilometers per hour. No problem. What am I going to do first? No, what am I going to do first? Thank you for figuring this out. There we go. So I'm going to go 4,356 terameters, and then I'm going to write a proper vertical fraction, and I'm going to choose to abbreviate years with an A. You can put a Y there. If you really want to, you can put a YRS and write extra. Okay. So Camille, we have to do 2 things. We have to change terameters to kilometers, and we have to change years to hours. Which one would you like to do first? Pick. To kilometers, that's going to be a 2-step. First thing I'm going to do is get rid of the terameters and put meters. Camille, tera is 10 to the what? Really? Yep. You're right. I was thinking 10 to the 9th, but I forgot about giga. Okay. Now, if I stopped here, that would be meters per year. I want kilometers per year. So I guess I'm going to put the M on the bottom to get it to vanish because it's on the top in the original fraction. And kilo. Camille, what's kilo? 10 to the? Top or bottom? Goes there. Goes where the metric prefix isn't. The kilo is already there. It goes where the K or the capital T, where the metric symbol isn't. Good. So if we stop there, that would give us kilometers per year. I want kilometers per hour. Alessio, you don't by chance know how many hours there are in a year, do you? Really? How many hours are there in a year? So I don't need to count. I happen to have it there. Well, that's handy. So now here's the key, Alessio. Where is years in my original fraction? On the, so it's going to go on the, and hours is going to go on the bottom, which, by the way, is where I wanted it in the end. And you're telling me 1 year is 8,760 hours? Well, that's convenient. If I hadn't had that number handy, I would have had to walk through exactly the same steps as we did for that question. Except because hours is on the bottom, everything would be flipped. What do you get? 4,356 times 10 to the 12th divided by 10 to the 3rd divided by 8,760. Do you get 4972602? Did I do this right? Yeah. Let's round off. Let's round this off in scientific notation to 3 sig figs. So, how would I round this off to 3 sig figs in scientific notation? 4.97? 4.97 or 4.98? You're right, 4.97 times 10 to the what? 8 units, kilometers per hour. This is the dimensional analysis or building a unit chain, a conversion chain method. Turn the page. In 2017, Mavis Wanchik won the single largest lottery jackpot ever in the US. She won $758.7 million. Let's do a little dreaming. Suppose she spends $1,000 per day. How many years will it take for her to spend the money? Now, this is a bit of a trickier question because we're applying it. So how the heck would I do this? I think what I'd like to first of all do is, if you spend $1,000 per day, I'd like to figure out how many days that's going to take you to spend it. So I'm going to start out by going 758.7 million. How many zeros gives you a million? You know, I could do the whole thing, but I'm lazy. I'm organized. I'm going to write million by just saying that. That's not scientific notation. That's not proper scientific notation. That's me just being totally lazy and saying millions is 6 zeros. And I'm going to divide that by 1,000. And that's going to tell me how many days. What do you get? $758,700? I don't know. We're going to prove it. Okay. I want to convert this to years. Do I know how many days are in a year? Yeah, okay, so we can go straight there. Where is days in my first fraction? On the top, so it's going to go on the bottom. Years is going to go on the top. 1 year is 365 days. Where is the 365 in my conversion factor? On the, so am I going to multiply by 365 or divide? It takes care of that for me. It tells me. If she spends $1,000 a day, can she do that in her lifetime? Not even close. All right, let's kick it up a notch. Suppose she spends $500 every hour. How many years will it take? Well, let's take that 758.7 million and let's divide it by 500 to see how many hours it would take her. So 758.7 times 10 to the 6th divided by 500. And I get it's going to take her 1517400. 1517400 hours. Alessio, do I by chance know how many hours there are in a year? What? So if I put hours on the bottom to get it to vanish and years on the top, 1 year is 8,760. So Alessio, here's the key question. Am I going to times by 8,760 or divide? How do you know? It's on the answer button, divided by 8,760. $500 an hour. Can she do that in her lifetime? Okay. Typically, when you win a large lottery prize, they give you a choice. You can have it paid out over 20 years in installments, or you can get a smaller lump sum up front. And she actually chose to go with the smaller, in air quotes, 480.5 million isn't really smaller. By the way, why would you take the money up front instead of having it paid out over 20 years? Yeah. Usually what the argument is. And also because as human beings, we don't delay our gratification. We eat the marshmallow all the time, anytime we can. It's just our habits, okay? So she's got $480.5 million. She's going to spend $10 a minute. How many years will it take? So we're going to write down 480.5 million. We're going to divide it by 10, and this is going to tell us how many minutes. You know what? I'm going to be lazy and sneaky. What are we dividing by? It's going to end up being 480.5 times 10 to the what? It's just going to be times 10. Well, if I divide by 10, it's going to knock off a power of 10. Do I know how many minutes are in a year? I don't think we crunched that. So what are we going to go from minutes to hours? Oh, and then hours to years. Okay, I got my conversion chain right now. So minutes on the bottom, hours, 1 hour is 60 minutes. And then hours, years, 1 year is 8,760. It's just an absurd amount of money when you start to crunch. Like $500 an hour cannot be spent. By the way, that $500 an hour would be assuming no sleeping, no eating, 24/7, right? 480.5 times 10 to the 6th, divide by 60, divide by 8,007, yeah, that. Did I do that wrong?
It should be 91.
Yeah, I did an extra power of 10. 91.4 years. So the fact that she's 53, really, she cannot easily spend this money in her lifetime.
But with that much money, she probably had to fight to make it worthwhile. Think about it.
It would depend, because at age 53, often your health problems are already pretty entrenched in your system, if depending on what lifestyle you've lived. So,
I can raise myself and see what happens.
by the way, preview of coming attractions, Aiden kind of raised a point. We actually, when we look at Einstein, we'll be talking about time travel, which is totally doable, by the way. And we'll be talking about why in real life, not Star Trek, not Star Wars, in quote unquote real life, if we do ever become a spacefaring race, going out to the stars on long journeys by being able to cryo sleep or something like that, you'll see you're going to want it to be a one-way journey. You're not going to want to come back. And secondly, there's some risks involved, but we'll talk about that when we look at Albert Einstein.
But like, about my deathbed,
I'm ignoring you. Hang on one second. I got to finish the lesson. So I'm going to pause right here because I've talked for just over an hour. We're going to take a break. You can work on the take-home quiz if you want to, but right now, as far as I'm concerned, you've got about 10 minutes to stretch. If you need to do a bathroom break one at a time, just let me know. So I wrote pause here. At the top on this back part, you can make a little note, not on, I'm not going to be putting this as a test question. This is just kind of nerd trivia. Enrico Fermi was a physicist who would often ask his students to solve a problem by making reasonable assumptions about unknown data. The idea was to provide a reasonable mathematical argument for your answer so that you could feel that your answer was, and here's your fancy phrase, within an order of magnitude. What does within an order of magnitude mean? It means that if we wrote it in scientific notation, the power of 10 would be correct compared to the actual answer. So if I make a guess and I say, it's about 5 times 10 to the 4th, and the actual answer is 9 times 10 to the 4th, I would say, wow, it was good to within an order of magnitude. That's all I care about. I got the zeros right. He was legendarily epic for this. He also was the person who started the first chain reaction of a nuclear atomic reaction. It was done underneath Chicago Stadium, of all places. This is pre-World War II, when they were just proving that you could actually start a chain reaction. He was on the team that built the atom bomb. Legendary physicist. There's an element named after him as well called fermium. So put your pencils down, look up. Number 1 and number 2, not homework. I'm not going to ask you to hand this in. But later on in class, I'm going to ask you to convince me. So here's your first try and see if you can come up with a good mathematical argument. If Pitt Meadow Secondary has 1,100 students, I would use 1,000 in my estimation. Estimate the number of pieces of note paper that the entire student body would use in an average year. I'll give you a hint. More than 10, probably less than 1 trillion. Somewhere in the middle. Question number 2. How far does an average person walk per year? Again, try and give me a convincing guess. I'm not collecting these. What is your homework? Number 1, you all have a take-home quiz. And number 2, I have a unit conversion practice sheet.